Hello, algebra students. Today we're going to look at simplifying radicals. And what that means is if you have the square root of something, like our first example, the square root of 75, if there is the factor in that 75 that is a perfect square, you need to go ahead and take that perfect square, which will bring that out of the radical. So let's just look at 75. There's the square root of 75, and there's a couple ways to do this. But one of the ways kind of illustrates what we're talking about. And that is you go ahead and factor 75 into two factors, one of which is a perfect square. So this time you might have to think about this. You might have to try a few numbers, but it turns out 25 is a perfect square, and that is a factor of 75. So there's what we have. Okay, I just factored the 75 into 25 times 3. Now 25 is a perfect square. So the way square roots work is if you have the square root of 25 times 3, that's the same thing as the square root of 25 times the square root of 3. Okay, and so the square root of 25 is 5. So now we have 5 times the square root of 3, and that is the answer. Now, that is considered simplified. In the original state of this problem that we had up here, that's not simplified. Okay, and it's not simplified simply because it can be factored into 25 times 3, and 25 is a perfect square. So if there is a perfect square that's a factor of that number, then to simplify it, you have to factor it into that perfect square times something else, and then you separate the two radicals like we did here, and then you can go ahead and take that square root of 25, and that's 5, and then the square root of 3 remains. Okay, so that's what's going on. That's not necessarily the easiest way to do these. It might look pretty easy in this case, but I'm going to show you another method that's just more straightforward. First, let's look at the next one, and we'll do it the same way, but sort of show the problem with doing it this way. We want to factor 242 into a perfect square times something else. And so, what is that? And you can keep a list of perfect squares. 2 times 2 is 4, 3 times 3, 9, and so on. And you can just divide all of those. And I'm not going to do them all, but we take 242 divided by 4. See if it works. Okay, it doesn't divide evenly. So much for that. So we take 242 divided by 9. Doesn't work either. So you can see it's a little bit tedious. 242 divided by 16. And there are some tricks you can use to help see which ones might work, which ones definitely won't work, and save some time. But basically, you have to just try them all. Here we go. 242 divided by, now 25 won't work because we can tell 242 is not divisible by 5 at all, so we don't have to check that one. If we knew some tricks, we might realize we don't have to check 36 either. Yeah, I think there's a way to tell that, but we're not going to worry about all those little tricks. So 36 doesn't work, then you can just keep trying things. And the one that works is we could write some more, and this, if we, once we get down to 11 squared is 121. Okay, so that's the one that's gonna work, but who would know that, right? And you have to try them all. So let's just make sure that really does work. 242 divided by, let's see what I do wrong here. Not very good at this calculator. There we go. 242 divided by 121. Okay, there it is. 2. It divides, and the other factor is 2. So we would say, okay, we got that figured out finally. And square root of 242 can be written square root of 121 times 2. And that's the same thing as the square root of 121 times the square root of 2. And the square root of 121 is 11. So we just replace it with 11, and we've got our answer. So this is a quick way to do it once you figure out what number to use, but finding that can be really tedious. So we're going to look at a straightforward way of doing these that does not involve trying different squares. Instead, you just follow this procedure. So we take 75. We're back on A. And you repeatedly divide to get all the prime factors. So you just divide by some prime number that you know goes into 75. So 5 will work. So 75 divided by 5. I don't think I'm going to keep bringing this calculator up. Oh, I closed the calculator. Great. Well, I'll bring it back up so you can use it later. So there it is. We'll go ahead and do this one since we have that up. 75 divided by 5 is 15. Okay, so okay, and then we divide that 15 by a prime that goes into it. And so that's 5 is 1, and then we get 3. And then if we have to look at 3, does a prime go into 3? Well, 3 is a prime. And so we're done. Okay, so now we're just looking for pairs of prime numbers in these final prime factorization. And first I'm going to draw a circle around all the numbers we're looking at. All those final numbers, the prime factorization of 75, that's what we're looking at. And we're looking for any groups of 2, any pairs. And of course this is it. We have 2 5s. Okay? So that means within a under that radical, there's 5 times 5, which is 5 squared. We pull that out, it's just going to be 5 on the outside, right? So we pull that out, and we have 5 on the outside. That comes from, again, pulling out those 5s. It's 5 times 5 on the inside, which is 5 squared, but on the outside it's just 5. And what's left inside is just the 3 this time, and that's it. And notice it is the same thing we got when we did it the other way. Okay, same thing. Okay. So let's look at the other one that we did already the other way. So we have 242. We're going to divide by 2, because that's a prime that goes into it. We can tell it's an even number, so 2 goes into it. And then what is that? Well, that is 121. Okay, and this is a little hard. What's the prime number that goes into 121? You have to play with that a little bit. So we get out our calculator. And we have 121. And so some numbers we might try. We're not going to try 2 because this is not even. There's a trick that tells us we don't have to try 3. And I'll go ahead and tell you that. You add up the digits of the number 121. Add the digits 1, 2, and 1. And then see, are those divisible by 3? Well, 1 plus 2 plus 1 is 4. Okay, 4 is not evenly divisible by 3, so therefore 121 will not be divisible by 3. So that's a trick. If we don't remember the trick, we can go ahead and try it. Okay, it's not. So now we're going to, the next prime is 5. We can tell it's not divisible by 5. The next prime is 7. Let's go ahead and try 7. Whoops. 121 divided by 7. Okay, that doesn't work. Next prime is 11. And that works. 121 divided by 11 is 11. Okay, so, and we actually knew that from before when we did the problem the other way, but we pretend we don't know. So we go ahead and divide it by 11 because that is evenly divisible. We get 11. Those are both primes. So now we look for the pairs, all the pairs, and there's just this one, a group of 2 that's the same. We take that out from under the radical, so to speak, and all the other factors stay inside, and that's just the 2 that stays inside. So you have 11 outside, and you have square root of 2, or you have 2 inside, so it's 11 times the square root of 2. And of course it does match the one that we got the other way. Okay, so let's do the rest of these. We'll do them the straightforward way using the prime factorization instead of just trying a bunch of prime numbers. You can actually, trying a bunch of perfect squares. You can do it either way, but the way using prime factors is just more straightforward. So let's do this one. Divide that by 2. I'm not going to use the calculator for that because it just takes a little longer. So that's 196. Now we have to divide that by something, and as long as they're even numbers, just stay with 2. I think it's the easiest. So what is that? That's 98, and gee, that's another even number, so just divide that by 2, and that gives us 49. That's not an even number. Okay, so what can we divide that by? Well, just 7. Okay, and then 49 divided by 7 is 7. So now we take out take out all groups of 2. So there's a group of 2. And look at this. There's 2 7s as well. Okay, so we take out 7 times 2. Let's look at something here. Okay. We take out a 7, we take out a 2. And they're multiplied by each other, right? That's the factors that have to come out. 7 and 2. And what's left inside is just a single 2. And so we won't leave it like that, though. We need to go ahead and simplify. 7 times 2 is 14. And now that is it. Okay? So let's look at the next one. So you might be able to look at this and say 9 times 7, 9's a perfect square. I think we can do it that way, but let's go ahead and do it this way using the prime numbers. So we're going to divide that by 2. That's a prime number that goes into it. We get 36. Well, handy thing to do is just divide that by 2 as well. And that gives us 18. And then, what do you know? That's still an even number. We'll divide that by 2. That gives us 9. And what goes into that is 3. And 9 divided by 3 is 3. And now we're done. So we're looking for the pairs of numbers, groups of 2, and we have a couple 2's there, and we have a couple 3's. So those come out. So you have 3 outside, you have 2 outside, and inside you have 2. And of course we simplify that. 3 times 2 is 6. And that's it. There's just a couple left. These problems are they're a little different because we have a number out front that we're multiplying. But that's no big deal. This just says when we're done calculating or getting the simplified form of square root of 180, we're going to also multiply that by 6 at the end. 6 times the square root of 180, sorry. So we just don't worry about the 6 right now. We just take the 180, we divide it. It's an even number. We get 2. We have the 90. And we divide that by what? Well, it's another even number. Let's just keep going with 2's. And we get 45. And what goes into that? Not 2 anymore. Let's go with 3. And then 45 divided by 3 is 15. Well, we might as well stay with 3 now, right? And then you have 5, and that's a prime. So we pull out all the pairs, and so there's a couple 2's, there's also a couple 3's. And they're not necessarily always going to be right next to each other either. So far they have been. So we take those out, so to speak. We have 3 on the outside, we have 2 on the outside, and then inside we have just 5. Okay, that's the leftover, so to speak. So now we could go ahead at this point and put the 6 back in there, right? Because we have right here, we've simplified, or the radical. We haven't multiplied the 3 times the 2 yet, but we will multiply it. But before we even do that, well, we could go ahead and write down the 6 that we're multiplying the whole thing by. Okay, remember that's up here. So now we got 6 times 3 times 2. And that is 36. So it's 36 times the square root of 5. And that's the answer. So just have one more. Do it the same way. It has a negative 8 out front. So we just kind of set that aside for the moment. 196. Okay. And we're going to divide that by 2. And that gives us 98. Might as well divide that by 2. It's even, right? Just do the easy ones first. All right? You don't have to try to figure out, does 3 go into it? Does 5, 7? What else goes into it? You don't have to worry about it. Do whatever's easy. And then as the number gets smaller, then some other things will get easy. So we divide 98 divided by 2 is 49. And there we have it. We might recognize, yeah, that's 7 times 7. So go ahead and pull out the 7. And 49 divided by 7 is 7. And now you have a couple pairs. Nothing's going to be left inside this time, right? Okay, the 2 comes out, the 7 comes out, so you have 2 times 7. And of course, the negative 8 is still there as well. So it's negative 8 times 2 times 7. And that is, we can punch that into a calculator. We get negative 112. Okay, so that's it. That's simplifying radicals. A couple methods. If you really like perfect squares and you know a whole bunch of perfect squares and you can spot them easily, this method might work, where you try those until you find a perfect square that does divide into it. So otherwise, might make more sense to use this method of prime factorization. You should probably do it some that way, at least, even if you don't do them all that way, because it's good to be familiar with that method.